For 2 seminars we have been talking about the theory and the physics about the magnetic flux measurements. Today we're going to look at how to measure flux more in practical detail. And before the analysis we did before that you have to make a measurement, and in general terms we have to know what to measure, how to measure it, and how to analyze it. I made these arrows because when you do a measurement it's good to know in advance how you're going to use the data and analyze it. So think about that when you plan your measurement. As I said, theory and analysis will not take up any of our time today, so we will go more into the practical details. In a general measurement you have to know what you have, what existing data, what production reports, and what, if there are any problems, is the company having with a certain machine. And then from that you conclude what more do you want to know. We go to the red part, and then if you want to access the machine you have to schedule it, talk to production maintenance, and since we're going to be working close to rotating parts, of course we have to do a risk analysis. The preparation of the machine before the measurement can often be done without you going there. Somebody from maintenance can mount a sensor, and also when you come there you have to put the machine in manual operation and also make sure the automatic voltage regulation is not in effect, because you want to do the test with open breakers and a manual control over the field current, so you can have a reduced field current and get a better reading without saturated steel in the machine. After that it's time to connect the sensors to the Chrome unit. We're going to look at that in real here with the machine or with equipment, and you enter the unit data into the software on your PC. And finally, depending on, now I'm going to talk about magnetic flux measurements, but usually you need to run the machine if it's vibration measurements, shaft displacement, or anything else. And in this case, as I said, we want to have a low magnetization. Compared to other measurements, this measurement is easy, as you will see, and a breeze compared to a full vibration and shaft measurement. In this case, we only measure 2 channels. The Hall sensor measures magnetic flux. The optical sensor gives you the position of the rotor. So the reflective tape should be on the shaft, preferably above pole 1. Makes it easier to look at the graphs later, and the optical sensor should give a blip when pole 1 passes the Hall sensor. Hall sensor should be mounted on a stator tooth, not over a wedge or an air duct, because first of all on the air duct you will hinder the flow of air, and also you will not have a good radial flux in either of those positions. The black part is the sensor, and it should be close to the center of the tooth. On the right picture is a bit below it, but we're still in the steel and we will have radial flux. You can extract the cables from the machine either by gluing them on a stator wedge, as in the left illustration, or stick them out through an air duct, as in the right picture. Here is an example of where I've been starting to take the cables out through the air duct, and here is what it looks like on the inside a while after I've pulled out most of the cable and before I'm gluing. And here's after it's glued. I use a 2-component glue that is not very beautiful, but it sits hard, and you can also use epoxy. Epoxy takes a bit longer to cure. This takes 1 minute, and with epoxy you probably want to put something like tape or some other pressure on it, so you don't have to hold your finger there all the time. With this one you just don't forget to use your gloves, because if you get stuck you're sitting there. Here's an example of how I secured the cables when they come out the back of the stator. And remember, at the back of the stator it's windy, so you want to have some form of securing of the cables. There's a checklist that you should go through before you make a measurement to make sure you don't forget anything. I talked about putting the generator in manual and how we want to have a low nominal field current between 50 and 75%, or rather between 50 and 60% of the nominal field current, so we don't saturate the steel, because that will reduce the difference between healthy and non-healthy poles. Just want to have a look at how, if you can see me. And of course we want to ground the equipment. We are having signal cables in the machine, and if there is an electrical fault or an insulation breakdown on one of the coils, we could get a current or at least some potential in the cables. The sensor has to be mounted. It's this checklist after all, and then the reflective tape on the shaft to give us the position. The whole sensor is powered through the USB from the computer, but the optical sensor has its own power supply which you have to connect to the Chrome unit. Connect the optical sensor, turn the sensor on. There's a LED indicator for the power to the optical sensor, and then it's time to have a look. So you get the signal from the shaft at the right position around the turn, and also take a small piece of reflective tape, if you don't have pole 1, towards where you glue the sensor and the optical sensor. Take a piece of reflective tape in your hand and make sure that you get the signal in the right position. Connect the whole sensor to the Chrome unit, turn on the software, and you will see a LED on the Chrome unit that shows you have power to the card and to the Hall sensors. You turn on the power to the Hall sensors, and you get an indication of the LED that you have that power. Then you adjust the current to the Hall sensors. So you have 1 milliamp that will give you a signal, correct signal out of the Hall sensor. And then finally, you enter the unit data into the software. So you need to know how many poles the machine has, and the rest of the data is information that will be transferred to the graphs when you analyze the data, so you can make nice graphs for export to the report. And when it's time to rotate, you have two options in software. You can monitor the signal to see that you have a good signal from your sensors, or you can select to measure. And what does this look like with the physical things? We're going to turn to the equipment now and have a look, and we're going to see what it is like to connect the sensors and adjust the Hall currents.
Hello, in this video I will show you how to set up the Chrome flux meter so you can do it yourself when you make a measurement on your generator. The most important thing is to remember to connect the system to ground. The generator should be set to manual operation to prevent it from reaching nominal voltage and synchronizing. In manual mode, the generator should be set to run at approximately 50% of nominal voltage or nominal field current. If you haven't done so before, glue a Hall sensor to a stator tooth. The sensor should not be placed over an air duct. You should also have placed some reflective tape on the shaft above pole 1. Connect the 12-volt power supply for the optical sensor to the flux meter. Connect the optical sensor. Now you can set the optical sensor to give a signal when pole 1 passes the Hall sensor. Connect Chrome to your computer and start the application. Now you can connect the Hall sensor to the flux meter. The easiest way is often to take out the cable from the Hall sensor through one of the air ducts in the stator. Power supply, where black is minus. We will later set this to 1 milliamp current, and the signal where green is signal low. You're now ready to adjust the current to the Hall sensor. use a multimeter that can measure 1 milliamp with some accuracy. Turn on the power to the Hall sensor and adjust the current. When 1 milliamp is set, flip the switch to bypass the multimeter and remove the multimeter. Before you start measurement, turn on the power to the optical sensor. The fourth diode, measure on, will blink during measurement. You are now ready to enter information about the unit and the measurement in the Chrome application.
What is that little box? Is it useful? Tell me about it.
I thought you'd never ask. It's a junction box that we put together after feedback from a customer. It contains screw terminals for the wires from the Hall sensor and a standard M12 4-pin connector that you can connect to the new sockets on the Chrome flux meter. It is intended as a convenient way to terminate the wires from the Hall sensor. It contains the screw terminals and instructions for which cable goes where, a bend protection with the strain relief. It can be a little bit tricky to get the wires in place. Sometimes you wish you had 3 hands. After you have connected the wires from the Hall sensor, you can connect the new junction box to the Chrome flux meter with the standard M12 4-pin sensor cable. Since the wires from the Hall sensor are quite thin, the metal pieces on the strain relief should be assembled like this. How you route the cables from the sensor or the back of the stator core will vary from machine to machine, but one way is to use a flexible conduit like this and put the junction box on the back of the stator. Then it is easy when you come back and want to make measurements in the future. For those of you who do not want to use this box, you can still use the screw terminals on the flux meter as usual. The Chrome flux meter has been improved with 2 new sockets. The socket for the optical sensor is still there. There's 2 new sockets for the Hall sensors. You can see the 12-volt power supply for the optical sensor and the USB cable connector for the computer. Thank you, that was interesting. But you see, I want to know more. That is a bit vague. Can you tell me why measuring magnetic flux is helpful? I guess there's also some software that goes with the big box to the right. Do you have any demos? All this sounds good, but isn't it difficult to perform a flux measurement? Yes, I will. I also need some documentation to show my manager. It looks like you have it all covered. The final question is, what does it cost? Thank you. It was nice talking to you.